அனைவருக்கும் வணக்கம். I am Dr. RS Boron, Assistant Professor in the Department of Chemistry, AG College of Arts and Science, Pudukkottai. Now I am going to discuss the extraction of boron from the minerals and the diagonal relationship between the boron and the silicons. Last one is the anomalous behavior of borons. Now first we can see the extraction of borons. Borons occurs in the combined state in the form of salts of boric acids, not in the free states. So boron is extracted from the some of the minerals. So the important minerals of borons: borax and borosite and colemanite and the boric acid, that is H3PO3. The extraction of borons from the borax or colemanites is most important. When extract from the borax or colemanite, boron can be extracted from the borax or colemanite ores in the two steps. In the first step, preparation of boron trioxide B2O3. From the borax, it is finely powdered borax converted into B2O3 by the heating with the concentrated HCl or H2SO4. For example, Na2P4O7, that is a borax, which is treated with the HCl, that is a form the sodium chloride and H2P4O7 tetraboric acids. Likewise, borax is treated with sulfuric acid and sodium sulfate is formed, and tetraboric acid also we can get. And these H2P4O7 tetraboric acid treated with H2O, so we can get orthoboric acid H3PO3. This H3PO3 orthoboric acid when heated gives the B2O3. So finally we can get boron trioxide from the borax. So another methods, we can get the B2O3 from the colemanite. The powder colemanite fused with the sodium carbonate and fused mass treated with water, in which the calcium carbonate is insoluble, so it's get precipitated. The filtered solutions having the borax and sodium metaborate, which is crystallized to get the crystals of borax first, and the remaining solution, the carbon dioxide is passed, sodium metaborate changed into borax. So obtained borax can be converted into B2O3. So Ca2B6O level, that is a colemanite, when treated with the sodium carbonate, forms the insoluble calcium carbonate and sodium Na2B4O, sodium metaborate. The sodium metaborate NaBO2 treated with the CO2, Na2P4O7 we can get, and also the sodium carbonate. The colemanite can be converted into B2O3 and other methods by adding the minerals in water passing the azotic gas. So we can get like a boric acid H3PO3. H3PO3 heated, we can get the boron trioxide B2O3. So these boron trioxides B2O3 by reduction of B2O3, the amorphous borons low purity can be obtained by reducing B2O3 with magnesium or sodium at a high temperature. So it is 95 to 98% pure and it is black in color. So another method is a modern method, that is the electrolytic methods. The boron obtained by the electrolysis of fused mixture having a boric anhydride, magnesium oxide and magnesium chloride at the 1373 Kelvin. The electrolyte is carried out in the carbon crucible, which acts as an anode, and iron acts as a rod is a cathode. The magnesium that is discharged at the cathode reduced to B2O3 into boron. For example, magnesium oxide Mg plus O2, B2O3 plus 3 Mg gives the boron and magnesium oxides. Another method is the thermal decomposition of diborane or other boron hydride gives the boron. That is B2 diborane heated gives the boron and H2. Another method, the reduction of the volatile boron compounds by dihydrogen at temperature 1543 degrees Celsius. Boron halides treated with the hydrogen. It gives the boron and HCl. Pyrolysis of boron halides, one orbital methods, Bi3, gives boron and halides. By heating potassium fluoride, KBF4, with the magnesium, it gives the borons. So these are all the preparation of the borons. Now we can see the physical properties. The borons exist as the two allotropic form, amorphous and crystalline. It has the two isotopic form, that is 5B10 and 5B11. It is very hard substance and the melting point is above 2177 degrees Celsius and boiling point 2552 degrees Celsius. It is a non-conductor of electricity. So now we can see the chemical properties. The boron reacts with the air, bonds under 973 Kelvin unit, reduced flame having the boron oxide. Borons reacts with the water. It is not attracted by the water under normal conditions. When the steam is passed over the red hot brown, hydrogen is liberated. And the borons react with the H2O to gives the B2O3, the H2. And another reaction is the reaction with the alkalis, that is sodium hydroxide potassium, gives the borate, corresponding borate. Boron plus 6 KOH, potassium hydroxide gives the potassium borate, the evolution of hydrogens, and reducing nature. It is a powerful reducing agents. For example, 3 carbon dioxide reacts with boron to give the boron trioxide and reduce carbon dioxide to carbon and silicon dioxide to silicon. Reaction with the acids. Boron react with the sulfuric or nitric oxides, gives the oxides of boron into boric acids. Whereas boron reacts with sulfuric acid, gives the boric acid plus sulfur dioxide. And reaction with the metals. Borons combined with the metals upon heating gives the borate. Magnesium to gives the magnesium borate. So boron reacts with the non-metals. It gives the boron halides. For example, boron reacts with the chlorine, boron trichlorides. And what are the uses of borons? So it mainly used as a semiconductor, and boron steel or boron carbide rods used for the control in nuclear reaction, as the boron has a very high cross section for capturing the neutrons. It can absorb neutron to create another boron having the number of neutrons 5B10 plus 0N1 5B11. So boron is used in the glass industry for making the specific type of glass. Boron filaments are used in making the light composite materials for the aircrafts. So these are uses of the boron. Now we can see the anomalous behavior of borons. What is the anomalous behavior? Boron is being the first element of this group, differ from the other element in its own group in many properties. The anomalous behavior of boron is due to the small size and high energy, high electronegativity, actions of vacant d orbital in its valency. So these are all the properties which are having the anomalous behavior. The important properties in which the boron differ from the other members of its group. Boron is non-metal, but other metals are metals. Melting and boiling point of boron higher when compared with aluminum and other members of this group. And borons only show the plus 3 oxidation state, while other elements are plus 1 and plus 3 oxidation state. The trihalide borons exist as the discrete monomer molecules, but other elements of this group exist as dimer having the halogen bridged structures. And boron show the allotropy and exists in two forms, crystalline and amorphous. Other elements do not show the allotropy. And boron cannot decompose water or steam like other members of the group, which can decompose water. And 7th point is boron is a non-conductor of electricity, but other elements are very good conductors. Boron combined with the metals to form the borates. Rest of the elements cannot form these borates. Boron show the maximum covalence of 4 in its compounds. Example, boron hydrides. Aluminum and other members of this family, so the covalence is 60 to the presence of the d orbitals. Boron forms only the covalent compounds. Aluminum, both covalent as well as ionic compound. Other members form mainly ionic. Oxide and hydrides of the borons are very weakly acidic. Aluminum and other members of the group is either amphoteric or basic in nature. Oxides of boron is soluble in water. Other oxides of elements are insoluble in water. Boron form number of series of hydrides called borate. The borate are stable covalent compounds, volatile nature. The hydrides of the aluminum and other members of the group non-volatile solids and less stable and decompose on it. So another topic is the diagonal relationship between the boron and the silicon. Boron is present in the third group. It is placed diagonally opposite to the silicon, fourth group in the periodic table. Therefore, boron shows the diagonal relationship between the silicon and the diagonal relationship is due to the atomic radius of boron, 85 picometer, is close to the silicon, 118 picometer. Both have the similar values of electronegativity. So, some important properties in which boron resembles with silicons. Occurrence. Boron and silicons are always found in the combined state. The second point is allotropy. Boron and silicons are allotrope. There are two allotropy forms, that is amorphous and crystalline. And third one is the non-metallic characters. Boron and silicons are non-metal, which is the high melting and boiling points. Both are non-conductor of electricity. And the fourth one is the semiconducting natures. Boron and silicon are semiconductor at a high temperature. Due to the high ionization energy of boron and silicons cannot form the cations easily. Boron and silicons can combine with the carbon to form the carbides. That is a boron carbide and silicon carbide. And the seventh one is the formation of hydrides. Boron and silicons can form the hydrides. One is the borane and the silicanes. And the eighth one is the reaction with alkalis. Both boron and silicons dissolve in alkalis form the borate and silicates. For example, boron reacts with the sodium hydroxide to the sodium borate, silicon with the sodium silicates. And the formation of halides form the halides when heated with respective halogens and halides, which are covalent in nature and hygroscopic and volatile and easily hydrolyzed by the water. For example, silicon chloride reacts with water which forms silicic acid. Likewise, the boron trihalide CCl3 reacts with water H3PO3, boric acid. Where the formation of oxides, both boron and silicons form oxides when heated in oxygen and the oxide B2O3 and SiO2. And the formation of the binary compounds with the metals. Both can react with, that is a boron and silicon, many metals forming binary compounds called borate and silicates. For example, boron reacts with magnesium, magnesium borate, silicon reacts with magnesium, magnesium silicide. Thank you.